have you covered the cross-sectional and time series analysis by now?
No, sir.
Oh, if no, then I don't know, because many things are in chronology, right? If you do not understand A for apple, B for ball, it will be not the ideal way to introduce some complex sentences using some adjoint or some other things. I do not know whether I'll be in a position to do justice to you or not,
But sir, I have studied the cross section or the time series
yes,
in
I
my
mean, I'm sure because
course.
majority of you may be belonging to economics, and nowadays in the UG level also econometrics is a core subject. No need to say that in the post-graduation level econometrics has to be there. I mean, gone are those days when econometrics and mathematical economics, quote unquote, was considered to be specialization subject. Now, no, now these are very elementary and core subjects like micro, macro, or international trade, polyfinance, or anything else. So given this assumption, let me proceed to the discussion forum. And in the panel data econometrics, there will be a sea of what you call modeling are available. And because of the paucity of time, I do not want to consume your valuable energy and time with respect to introducing a number of modeling right now. Rather, the basic modeling, what is my plan is that to introduce the basic concepts of panel
Sir,
data.
sorry to interrupt you in between. There is a screenshot of your meeting that is being overlapping with the slides.
Okay, so
So
should
that,
I minimize it,
yeah,
right?
yeah, yeah, yes, sir. Now it's fine.
Okay. So what I plan to introduce the concept of panel data. How does the panel data look like? And what are the merits and demerits of panel data over the cross-sectional and the time series analysis? Then the second part of the discussion will be with respect to how do we estimate. Like any regression techniques have certain procedures to estimate. Basically, the parametric estimations here we are talking about, not parametric tests. So although panel data have its own version of non-parametric analysis too, but in this current 1 hour session, we are focusing on the parametric aspect of it. And then subsequently, the third portion, with the help of certain software, it may be Excel, it may be Views, it may be Stata, even if you the help of Python also it can be done. No need to mention that any sophisticated softwares will not give you any different type of outcome. The outcomes will be more or less similar. It may be 0.001 or 0.002 kind of difference, and it is not the case that if we use AI ML technique, then our result will be more robust or more significant. And if you use Excel, the results will be not that much attractive or lucrative in nature. That is not the case. So what I'm trying to show is here, not with the help of Stata, I will not do execute anything right now, but I will show that if you use the Stata software, then how does a panel data econometric technique can be understood. Basically, focus will be the interpretation part rather than going through any hands-on training, because within 1 hour to do justice with everything is not practically feasible. So with this background, let us proceed further. So as we know that the data is a set of information. So accordingly, those set of information, whenever they are categorized, whenever they are classified, they belong to three categories. Either one is a cross-sectional arrangement. The second one is known as a time series analysis or time series data. And the third one is known as a pool data or something called the panel data. Subsequently, I will give you a clarification that how does a pool data analysis is different from a panel data. Both of them are not same. To start with the cross-sectional data, as you can see from this figure, that here in this case, we are showing two farms. One is a farm 1, another is a farm 2. And both of them are available for the same time period, let's say consider 2020. And there are three variables over here. No need to say that in econometrics, we generally use Y and X to represent the dependent and independent variable. And whenever the independent variables are more than one, we call it as a multiple regression analysis. And whenever the right-hand side of the independent variable is only one, we call it as a single regression model. So in this case, we are talking about a multiple regression model where the dependent variable is one Y and there are two independent variables. And now the arrangement is like this, though it is not necessary that it has to be necessarily two farms only. There can be any n number of farms. The n can be 10, 20, 30, 50, 100, 1000, any number. To give an example, that if the farms will be two or more than two, and all the farms will be analyzed for a single time period where the time is not changing, only the cross-sectional element is changing from 1 to 2, 2 to 3, or any n number, then we call it as a cross-sectional data. So in this case, the time period is fixed, and the cross-sectional element may be farm. It can be with respect to any other analysis, can be a region, it can be company, it can be country, etc. But the country may vary from 5 countries to 10 countries or 1,000 countries. The industry can be from manufacturing to agriculture or services sector, etc. So in that case, the arrangement we call it as a cross-sectional data analysis. And the corresponding econometric modeling, we call it as a cross-sectional econometric analysis. It has its own area of discussion. I should not go into that detail. Anyway, slightly we'll touch upon them, because panel data analysis will be a combination of both of them. So in order to start with the panel data, my objective is to introduce the cross-section as well as time series element to be introduced. So next thing is that whenever we call it as a time series data, so here, as you can see, the year varies from 1 to many. That means suppose we have for any one cross-sectional data, let be farm level analysis only. So for example, suppose there is a Ayush sector company, like for example Dabur or maybe Patanjali or something like that. Then suppose Patanjali data for any particular variable, Y may be something, suppose profit, and X1 and X2 may be with respect to some other type of farm specific variable, like suppose R&D investment or inventories, or maybe asset turnover ratio or something like that. So all them are independent variable, and your dependent variable is Y. It can be profit, it can be anything else, productivity or something like that. But the thing is that the company will remain the same. In the time series data, the cross-sectional element will not vary. Only for the same cross-sectional element, the number of years will vary. And obviously, as we have seen that cross-sectional element may be 2 or more than 2. Similarly, the number of years should be also 2 or more than 2. If the cross-sectional is 1 and the time period will be 1, there is no point. So obviously, either you keep the cross-sectional fixed, vary the time period, then it's a time series analysis. Or if you freeze the time period and change the cross-sectional element, then that will be cross-sectional data. What is the how does a panel data look like? So whenever you are clubbing them together, like farm 1 is having information for 3 years, like over here. Farm 1 is having information for 3 years. Farm 2 is also having information for 3 years. Then in that case, we call it as a panel data analysis. So what happens over here? It is not only the cross-sectional element is varying from more than 1, it is also the time period is also changing from more than 1. So obviously the cross-sectional, each cross-section will be covered for more than 1 time period, as well as the cross-section will also be changing. So in that way, we call it as a panel data. So how does a pool data is different from panel data? Only thing is that if you club them together, if you consider the different farm level analysis and compile them in different time period, and if you just club them together, then we call it as a pool data analysis or pooled regression model or pooled data itself. How does it different from the panel data? In a pool data, the same company or the same farm is not necessarily to be repeated. For example, suppose if you go for an FHS data analysis where the population is the subject matter, I mean, what you call the target audience or the stakeholder. So in that case, the same population will not be covered in the different rounds of the NFHS data. Maybe in 2005, the same population will be different with respect to 2010 or maybe 2018 or something like that. The population will not be the same. Had it been the same, then we call it as a panel data. If we are targeting for the same 500 population and we are getting their information over a period of time from 2000 to 2005 or maybe 2007, etc., it need not to be the same annual frequency. The frequency may be more than 1 or maybe less than 1, depending on the nature of the panel data or the pool data that we consider, that we subsequently discuss when we will go into the details of the different types of panel data. For the first of all, for the very outset, The pool data is different because the same farm may not be necessarily the case. And if you consider the same farm over a period of time, we call it as a panel data analysis. Is it clear right now, till now?
Yes, sir. Yes, sir. Yes, sir.
Okay. So moving further, that whenever we are approaching the panel data, now there are two types of panel data. One we call it as a balanced panel data, another is considered as an unbalanced panel data. For the balanced panel data, as you can see the examples, that if you are considering the farms, now the farms will be having 1, 1, 1 is repeated 3 times because the time period is 3, 20, 19 and 18. Farm 2 is also repeated for 3 time period. Farm 3 is also repeated for the same time period. So don't be confused that the number of cross sections should be equal to number of time period in the case of balanced panel. That is not the case. Rather, whatever may be the number of cross sectional element and whatever may be the number of years, they should be remaining the same for across the cross section. Whereas in case of unbalanced panel, as you can see, the farm 1 is collected data for only 2 time period. Farm 2 is collected for 4 time period, 3 time period, and farm 3 is collected for only 1 time period. Because of the data unavailability or because of some other regions, if you cannot find the data for all the farms for all the years simultaneously, then that type of analysis will be unbalanced panel data. And obviously, whatever discussion we'll be going through, we are going to cover now, they will be broadly with respect to balanced panel, not with respect to unbalanced panel, though majority of the modeling can be fitted, but obviously because of the nature of the data will be different, so accordingly unbalanced panel modeling will be relatively different with respect to balanced panel. So that is the concept of balanced panel over here. If you are considering suppose 10 farms and each farm is repeated for 5 times, so accordingly the 10 into 5 will be the total number of observations will be 50. But whereas in case of unbalanced panel, that is not necessarily the case. That means that maybe all the 10 farms will be covered, but maybe the first farm will be covered for all the 5 years, second farm will be covered less than 5 years, maybe the third farm will not be covered at all, because that may be the possibilities also. So in that case, that will be the nature of unbalanced panel.
Sir, I have a question. Sir, but when we see the real data, that if we see the CMI province firm level data, so there you find if you have an analysis related to the firm level analysis, then when you see the data, then there is that you find that a firm has many the missing data in the subsequent years. Then how to make it then balanced panel? In reality, basically the mostly we find the unbalanced panel.
Yeah, true. So in that case, the modeling will be different. We should not be going for the pooled OLS, FERE, ME model, whatever we are going to discuss. That should not be the ideal way to do it. Though if you use it, there will be no problem because, but the corresponding coefficients will be relatively, either biased or inconsistent. The whatever we call it as the blue properties will not be holding, or there will be some other type of challenges may come. So majority of the times what happens, though people they will be going for extrapolating the whatever the variables. So if you are having some of the variables for suppose 17 years or 18 years, and if all the other variables are available for 20 years, then for the next 2 to 3 years time period we can extrapolate the data. But that is also not a rigorous scientific way to do that analysis. So better resulting is that if you use the unbalanced panel model also in the Stata thing, in the Stata software, basically, I'm not talking about other softwares. What it will do, it will take it as it is an non value, missing value. Kindly be serious about it, that if you put any other number other than black figure, because black means we do not know what is the number inside it. But if you put it replaced by some 0 or 1 or maybe average figure and do an extrapolation of items, then accordingly the result will be changing. The significance level may be affected. So in that case, there will be both pros and cons of the balanced and unbalanced. But obviously, if you have a balanced panel model data, then that will be easier for us. And it is not necessarily that it should be a perfectly balanced. Majority of the variable in the CMA database, if you use it, we may get it as a strongly balanced. Like for example, if you focus on the manufacturing data, especially for suppose food and processing, beverage industry or so and so, then accordingly, suppose we are taking 100 farms, then the 100 farms may have a whatever we call it as the representation for almost 70-80 farms. The figures will be available for the almost 15 to 20 years. So that will also be fine. But if you consider 100 farms and accordingly only 30 farms are having significant number, then it will always be wise to cut them down. No need to focus on 100 because CMI database claims 100, but at the time of giving data, it will give us only a very insignificant number of companies. So better way is to remove them out. Obviously, removing them out also have some more challenges. So in that way, econometric modeling has its own pros and cons. Balanced model, balanced panel data is very good. I mean, ideally, like in economics, we call perfect computation market is very good so far as consumers' efficiency or social welfare is concerned. But hardly we come across with that type of competition market in our day-to-day life, isn't it?
So if we have a, let's say the 5,000 firms, and let's say there is some 7 8 firms have not enough data, have the all the variables, then simply then we can drop that
Yes,
firms.
actually there are two ways of dropping it. If you are having at least the rule of thumb says that it will not be written in any textbook. The rule of thumb says if you are having at least 60 to 70% of data, like for example, company B is there, where the company's B's total data coverage is for 20 years, and we are having data up to for 12 to 13 years, more than 50 or more than 60%. So let us keep it. It will be not balanced panel data, but let us keep it. And the second thing is that if you are having the data not continuously from 2000 to 2016-17 and the last 5 years data is missing, then that will be well and good, no problem. Majority of the data will be like first year, then second and third, fourth year is missing, then fifth year, then for the next 3 years it will be missing, then it will be for the next year, and so on. So in that way, if a particular company's data is not, available for at least 3 time period continuously, then accordingly you should be deleting it. The deletion will be very easy. If you're not getting balanced panel, it will be let us delete it. But if you, as you go on deleting the data or deleting the company, there will be degrees of freedom problem. There will be problem with respect to estimation findings. So in that way, you have to be very careful whether you will be keeping the data as it is, whether you will be going for extrapolation and make it as a balanced panel, or whether you want to keep the data or you do not want to keep the data at all, you completely delete it. So it will be completely up to the objective of the researcher. From the very outset, there is no such magic wand with us that say that this is the solution for this type of data. Am I clear?
Yes, sir. Yes, thank you, sir.
So further, suppose we are going for again balanced panel data, then balanced panel data will have again 2 dimensions with respect to the number of cross section and with respect to number of time period. If the number of cross sectional element, like in the left hand side panel, we are considering only for the 3 farms, and we are considering the year will be for 2 years. That means here the n, which is representation for the cross sectional element, is 3. And here the t, which is the representation for time period, is 2. So that means n is greater than t. So in other words, t is less than n. So whenever t is less in comparison to the number of cross section, we call it as a short panel. And whenever the reverse is the case, that means we are considering suppose 3 farms and we are taking into considerations suppose there will be more than 3 years time period available. So in that case, we call it as a macro panel data, or we call it as a long panel data. So if the t is greater than n, t greater means it is long, t less means it is short. So in that way, the short panel and the long panel is different. I'm sorry, the right hand side numbers are just the repetitions. Credit goes to the research scholars, those who are asked to do this what you call tabulation thing, and they just copy and paste. I have not checked it. This is my mistake. I'm sorry for that, but this is not exactly the long panel. Rather, it is just the repetition of the short panel. The idea of the long panel is that if you are taking 3 farms, the year should be more than 3. And if you are taking 2 farms, the year should be 3. That is the idea of the long panel. Any question?
Sir, yes, sir. Can you explain again, sir? I am unable to understand, sir.
Which one?
Short panel. Sir, short
Short
panel
and
and
long
long
panel.
panel, sir. This
Okay.
one, yes, sir.
So let us take another example. For example, suppose we are talking about foreign direct investment getting into the different countries. And suppose we are taking three countries. One is Brazil, another is India, another is China. And they are related to with respect to different time period. For example, the different time period means we are taking for the last 2 years, 2024, 2025, especially in the geopolitical crisis period. How does the emerging countries behave? That is the objective of a researcher. So in that case, your cross-sectional element is three. That means Brazil is one country, India is second, China is third country. So your cross-sectional element is three, and your time period is only 2024 and 2025. For taking any variable, let us say for taking into consideration foreign direct investment. So your Y variable will be foreign direct investment. It may depend on X1 and X2 in terms of GDP per capita or in terms of exchange rate volatility, etc. We are not interested to go into the details of the nature of the variable. Whatever may be the Y, X1, X2 does not matter. Only this arrangement has to be seen. How does the cross-sectional is different from the time period? If they are same, then accordingly we call it as a balanced panel. And if the cross-sectional element is higher, then accordingly we call it as a short panel, because time period is for 2 years and cross-sectional analysis is for more than 2 period. It is not necessarily 3 versus 2. It can be 10 versus 2. It can be 100 versus 97. There is no such problem. The time period should be sufficiently, I mean, at least one small with respect to the cross section. N is greater than T, then it is a short panel. If N is if N is less than T, in other words, T is greater than N, T stands for time, then accordingly we call it as a long panel. If you change this example by saying that keep the country for three cross section, Brazil, India, and China, but let us consider for the last 5 years. That means after the corona time period, COVID time period, 2021, 22, 23, 24, 25, if you are considering 5 time period, then in this case, T becomes 5 and your cross section remains 3. So in that case, we are considering as a long panel data.
Yes, sir. Got it, sir. Thank you, sir.
Okay. Then the next version of the modeling is that we call it as a dynamic model. Dynamic panel modeling has different type of other varieties, especially the most what you call the popular is something called the generalized method of moments, GMM, etc. Again, my objective is not to go into the details of the GMM modeling right now, but if there is a question, we may discuss it towards the end of our discussion. But the idea behind dynamic panel data is that whatever may be the nature of the panel, whether it is balanced or unbalanced, whether it is short or long, doesn't matter. That topic, that portion is covered now. Now, only difference between the static model versus the dynamic model, like the previous cases, whatever we are discussing in this slide or maybe this slide, we are not discussing the dependent variables lag period. Like over here, if you focus in this dynamic panel, whatever may be the Y dependent variable, there is another right hand side variable what we call it as a yt minus I. T minus I represent over here that the last 2 years data of the same dependent variable will be considered as something called the right hand side variable. Last 1 year data, last 5 years data, accordingly this is yt minus I. Generally, in annual data, when the frequency of the data is annual, then we consider the I should be as 1. That means yt minus 1 should be the ideal way. If the nature of the dependent variable is something called quarterly data, generally we may go for 3 quarter lag of 3 quarter. Or if you're considering for a monthly data analysis, then we may go for last 10 or 11 what you call month. So in that way, we cannot consider it as a yt minus 1 only, rather we call it as yt minus I. Yt minus I means over here, like in this case, 231, 334, 436, there are 3 observations which is in the Y. And in the yt minus 1, what happens? The 334, that means the 2020 is the latest period, 2019 is its previous period. So previous period's dependent variable will be considered as a independent variable. and the 2018's dependent variable will be considered as a dependent variable. Obviously, because the nature of the variable is for 3 time period, the lag period will be available for only 2 period. Had it there been before year, then accordingly we may go for 3 period, and obviously 1 period will be left blank. The left blank because the gap will be available for 1 period. If you consider first quarterly data, then accordingly the nature of the data will be different. This is the arrangement. Now, what is the logic behind this? The logic behind this is that majority of the economic variables, wherever there is a time element arises, obviously the changes in the variable, like for example, if the GDP figure of today will be high, let us say the GDP figure for India in 2025 is suppose $4.2 trillion in United States dollar measurement. So in that case, if the previous data of the GDP, if it will be more, then there will be a larger chance the GDP will be bigger in this year, though there is no hard and fast rule behind it. Only because that we call it as in economics or generally in the logic approach, we call it as an agglomeration effect. Agglomeration effect means if the figure is relatively more, then accordingly in the next period, the figure will be relatively further more. So if the GDP figure is rising today, then there will be a higher chance that the GDP figure will be a bigger figure in the next one. Or the GDP figure is falling, then accordingly there is a higher chance that the figure will be relatively less in the subsequent time period. And that's why we consider it as an agglomeration effect. Sometimes we call it as a network effect also. For example, if the dependent variable is migration. So suppose we are considering the migration is the dependent variable. So in that case, we may consider the network effect of the migration. If the previous year the migration is more, then there is a higher chance that the next year also the migration will be more. If the migration is relatively shrinking, then accordingly we call it as the network effect is losing down. So in order to capture that agglomeration or the network effect, we use the dynamic panel model, and that is the only difference between the previous model where there is no mention about any YT minus I. Rather, whenever we use this YT minus I as an independent variable. So the dependent variable is I, independent variables is still x1 and x2. In addition to those two independent variables, we additionally use YT minus I as a third variable. So in that case, whenever there is a presence of YT minus I, it is a dynamic panel. If there is no presence of YT minus I, like the previous case, this case, or maybe the first case, so we call it as a static panel model. The difference between static and dynamic panel model, is it clear now?
Yes, sir.
Yes, sir, it is clear. Okay. Sir, what is GMM?
What is?
General method of movements. What does it mean?
General method of movement is an advanced version of dynamic panel modeling. So whenever the nature of the data arrangement is like this, like the way in which we are seeing this slide number 6 right now. So whenever the arrangement will be like this, we cannot use the normal linear regression model the way in which we do. Anyway, I have not also shown you that how does a normal regression look like. That is our objective to discuss right now. So in that case, whatever the normal linear regression modeling we are using, that will not be the consideration in case of the dynamic panel. So for that, we have to a modified assumption or a modifications is required. For that, we have to use the method of moment condition. The method of moment condition will be coming from the concept of the moment. Like if you remember something called, there is something called skewness, kurtosis, moment condition. So from that moment condition, moment of first order, moment of second order, there are various versions of moment conditions available. And from that method of moments, we have to generalize something with the help of weighing mechanism. There will be n number of things inside it. So basically it is capturing the endogeneity issue in the econometric modeling. What is that endogeneity issue, etc. So that's why I do not want to go into the details of that GMM model, but GMM is basically an example of dynamic panel modeling. I'm just touching up on the concept. I'm not going into the details of it. Is it clear? If
yes,
there is
sir,
a
yes, sir.
towards the end, then we may discuss it more detail.
Yes, sir.
Okay.
Thank you, sir.
Then the next thing is that, so what is the problem if even if there is a panel data model, what is the problem? That's why I asked in the beginning that whether we have understood the time series analysis, whether we have understood the cross-sectional analysis. If yes, then accordingly, whatever we understand, we will apply it. Like if the face problem is available, whatever is there in our mind, we generally try to use that limited knowledge to understand or to give an answer. Maybe appropriate, may not be appropriate, that's a different story, but we'll try to do that. So if you have understood the time series regression, what we'll say that yt will be a function of x1 and x2, like this is the nature of the model. And if you have understood the time series model, so what we'll do that, let us fit a time series model. Instead of it, let us consider as yt. So there are farm 1, farm 2, farm 3. There are 3 farms. So let us do one thing. Let us do a OLS, as ordinary least square modeling. So what happens for farm 1, we'll be considering the 2020 to 1918. So this is the break of the total model. And for farm 1, we'll do a time series analysis. Farm 2, there will be another time series analysis. Then for farm 3, there will be another time series analysis. So there will be 3 models, and there will be a time series regression analysis, and accordingly we'll get the result. So it is a big deal in it. Now the problem is that if you do this type of analysis, that is not the objective of our research. Our objective is to get into consideration of cross section as well as time series. So we are considering right now in this type of approach, we are considering only the time series analysis effect, but we are overlooking or we are not considering the effect of the farm specific characteristics. So accordingly, if the farm 1 is independently estimated irrespective of 2 and 3, then where lies the problem? Where lies the challenge? Where lies the benefit of doing a longitudinal data analysis? We should do it considering all the farms for all the years, then that does make a sense. So that's why if you do fit a time series regression and estimate a time series model of each farm using OLS, then this type of result will give you 3 different regression model. But we are not interested in 3 regression model. We are interested for a single regression model where there is a cross section as well as there is a panel time series element. And we end up with a disparate pieces of information, because that type of analysis will give us picture for farm 1 only independent of farm 2, 3, farm 2 CFET only independent of farm 1 and 3. So in that way, there will be a very skewed type of analysis we are going to do. And similar is also the case if you do a cross-sectional analysis. Cross-sectional means irrespective, instead of going for a time period analysis, what we'll do, we'll be going for something called for each year, like for 2020, farm 1's information is available, farm 2's information is available, farm 3's information available. So for 2020, farm 1, 2, 3 cross-sectional element, and then do the regression. Similarly, for 2019, farm 1, farm 2, farm 3 information is available, then go for it. Then that type of cross-sectional regression analysis will also be a problematic thing, because again, that is not our objective. What happens to the farm 1, 2, 3, all the 3 things are covered in a single model. But what happened to the time period? Only for 2020, there will be a regression model. For 2019, there will be another regression model. For 2018, there will be another regression model. So we are not interested to do the multiple regression model for multiple time period, because in that case, the time period effect analysis will not be captured. So our objective is to capture both the farm level situations as well as the time period situation. Otherwise, if you do not club them together, there will be no point of doing a panel data or a longitudinal data analysis. We must be interested to know that if you are analyzing the foreign direct investment behavior for Brazil, India and China for suppose 4 years or 3 years, whatever, then accordingly as the time change and as the country changes, how does the FDI behavior change? And which variable is affecting that FDI behavior, whether the GDP per capita as X1 variable is affecting that, or whether it is the exchange rate volatility which is affecting that foreign investment. That is our subject matter. So if you do this type of approach, then we will not get our appropriate result, or that is not the right way to do the thing. So these are the 2 things which is not going to help us. Rather, there is another way also. Because cross-section and time period is analysis available. So what happens over here, we'll be going for 3 farm level analysis instead of going for different time period, because time period will be varying from 18, 19 and 20. So what is done in this type of analysis, we are going for averaging out. It was 231 plus 334 plus 436. 3 divided by 3 will be another figure. So accordingly, all the variables are, the model is like this. So we are getting a cross-sectional regression model, but only thing is that it is not the dependent variable, rather it is the average variable. Average variable over the year, average out with respect to time. So in that way, we call it as something called between group cross-section regression. And this between group cross-sectional regression is also not the valid way to do the analysis. Reason behind is that this is obviously with respect to average figure. And we are not interested for average figure because in 2020, maybe figure will be very high because of the time specific reason. Maybe because of that is a COVID region, or maybe because of some climatic change region, maybe some natural disaster, maybe some war crisis. So because of that particular thing, because that particular thing is happening in a particular year, so that year specific figure will be affecting. And if you average it out, then there will be no such what you call effect of the time will be captured. So whether we use the time series model to do the panel data econometric model, or the cross section, or this between group cross section regression model, these are not the appropriate ways to do the panel data. So like the other ways, we start with the do nots, then we'll consider something called what to do. So what to do, that is the region because of which we'll do a panel data regression model, where the nature of the panel data will be like this: short, long, balanced, unbalanced, whatever may be the region. What we are going to cover them, we are not only interested to cover the cross-sectional specific variable, we are also interested to cover the time specific variable. So accordingly, taking into consideration all the cross-section form specific variable or the time series variable, how do you do the estimation? So for that, the estimation method, we are going to depend on three things. One is a pooled OLS method. Second one is a fixed effect model, and within the fixed effect model, there will be three versions. One is called the least square dummy variable model, LSDV model. Second one is called the within group estimated model that we have somehow partially covered in the beginning also. And then third one is known as the first differences model. And the third one with respect to fixed effect model is called random effect model. So there will be three modeling altogether, and within the fixed effect model, whatever the sub variations are available, we will also discuss them one after another. This is the first part of the story. I have taken a large time period. I'm sorry for that. Till this particular portion, is there any problem? Because the introductory part is getting over now, and now we are going into the details of some modeling portion. So if it is okay, then we'll be proceeding further. And before going to proceeding further, I just want to know what is the nature of the understanding with respect to the modeling. Otherwise, my focus will be with respect to the interpretation part and what is the challenges with respect to pooled OLS and fixed effect, etc. And we'll be not going into the derivation part. Otherwise, if you are interested for the derivation part, I am also ready to proceed accordingly. Please respond me, because I am not looking at the, what do you call your.
Sir, we can go into the derivation part with some examples where it can be applied.
Exactly. Okay. Fine. So in that case, I'll not bore you out with respect to the assumptions or the problems associated with pooled OLS. As we have shown you previously, that pooled OLS means the ordinary least square method, and obviously it is not necessarily for a panel data modeling. Rather, it is applicable for pooled data. But what does it mean? Whether the nature of the what you call the cross-sectional element, whether they are repeated or whether they are varying from one time period to another time period, does not matter. So in that case, the major challenges with respect to pooled OLS is something called heterogeneity, which means that unobserved characteristics. I should not write form specific one, but because from the very beginning I am using the form as a cross-sectional variable, so accordingly I may use form specific characteristics, but it does not necessarily related to form only. Depending on the cross-section, whether you are doing a industry level analysis, then it is an unobserved industry characteristics. If it is a country level analysis, then it is an unobserved country level characteristics. If it is suppose a plant level characteristics, where the actual production took place, then accordingly it is an unobserved plant characteristics. If it is a suppose something called district level analysis, then accordingly unobserved district level characteristics. What does it mean? In case of any particular cross-sectional element, let us take consideration about form specific characteristics. For example, suppose we are taking textile industry. So within the textile industry, suppose there are 50 firms. So what happens over here? If you deliberately assume that all the 50 firms within that textile industry, they are homogeneous in nature. There is hardly any heterogeneity. That means there is no consideration of a big farm, small farm. One farm is doing advertisement aggressively, another farm is not doing aggressively. One farm may hire something called very skilled workers, another farm may not have any skilled workers. One farm may have foreign ownership, another farm within the same industry may not have foreign ownership. So all these things are considered as a farm specific characteristics. And what we are assuming in case of panel data modeling is that each farm within a particular industry, they are assumed to be heterogeneous. That means they should vary from, the characteristics should vary from one farm to another. And in the pooled OLS model, what we generally do is that we close our ear and eyes and say that no, there is no difference across the farms within an industry. Textile industry is textile industry, whether it is a farm 1 within a textile, farm N within a textile, does not matter. So in that is the assumption, then accordingly we are going for pooled OLS. And obviously what we understand that is not necessarily right way or right assumption. So accordingly, whenever the pooled OLS is used, we assume heterogeneity is missing or missed out. There is no heterogeneity across the cross section. So if that is the case, no problem, we can use the pooled OLS. But if you know that the heterogeneity will be there, then accordingly, if the heterogeneity is there, we should not use pooled OLS. Rather, we should go for either fixed effect or the random effect model. Is it clear?
Sir, I have one question, sir.
Yes.
Sir, in all the farms, there is some heterogeneity is there. So whether we have to use pooled OLS methods?
No. It is not necessarily that whether heterogeneity is there or not. I mean, it is not on the basis of assumption only. Like it depends on the nature of the industry. Like for example, suppose if you take a SIM card industry, right? I do not know whether it is a SIM card industry or not. Telecommunication related, any particular product like SIM card, right? So what happens over here? There will be 5 or 6 big farms. There may be some small farms. Hardly there will be 10, 12 companies altogether. But so far as the pricing mechanism is concerned, the particular SIM product, there will be hardly any difference with respect to the texture, with respect to that software quality or etc. So there will be obviously from BSNL to Jio, there will be difference. From Jio to Bharti Airtel, there will be difference. No, I mean there is no complaint about it. But if that difference is very marginal, and there is hardly any thing in consideration, then accordingly we may consider it as a very homogeneous type of thing. And on the basis of assumptions, we may go for pooled OLS. Ultimately, on the basis of assumptions only, will not do the modeling, right? Even if the assumption may be correct or may not be correct, so there will be some diagnostic checks to do so. So ultimately, if there is a pooled OLS you do, then you go for an alternative model like fixed effect. There is another alternative model called random effect model. Then accordingly, there will be some diagnostic checks will be done. So which particular model is suitable for your data? So accordingly, if the diagnostic checks will give a green signal for pooled OLS over FE and RE, then you go for pooled OLS. If the green signal, obviously that diagnosis will be based on the heterogeneity thing into consideration. That means there will be marginal heterogeneity, and accordingly you may skip it or you may overlook it. But if that heterogeneity will be very significant, the diagnostic checks will not give you the green signal. Rather, it will say that pooled OLS is not appropriate. Rather, you should go for the alternative model. So accordingly, there will be some scientific tool that we call it as a Haussmann test, Bruce-Pagan-Langren's multiplier test. There will be some other type of things are available. We'll be also proceeding into that. How do you come to this conclusion whether pooled OLS is appropriate or not, and whether FE is appropriate or not? So we'll be exploring it gradually.
Yes, sir. Got it, sir.
Okay. So next thing is that whenever we are proceeding from fixed effect, I mean pooled OLS to fixed effect, so we start with the similar type of modeling. That means dependent variable is a function of one independent and the second independent. What is the speciality of the fixed effect model is that in addition to this model, and obviously the last term is known as the error term, right? And the error term has different type of terminologies also. Sometimes we call it as a white noise term. Sometimes we call it as a residual terms. Sometimes we call it as a IAD term, IAD distributed term. So accordingly, there will be various versions of it. What happens over here, in addition to this panel data model, what we are going to do, we are adding certain firm fixed effect. Firm fixed effect means what? Whatever may be the number of firms will be considering their dummies. That means if you are taking 3 firms, accordingly we'll take 2 dummies. And what will be the nature of those dummies? Those dummies will be something look like this. We call it as a LSDP dataset design, because the first procedure of fixed effect model is that we'll be going for something called least square least square dummy variable regression model. So what we are doing over here, we are adding additional 2 dummies. Why 2 dummies? Because the number of firms over here are 3. So accordingly, if you take three dummies, then we will be getting into the problem of the dummy variable trap. So that is the idea, that how many cross-sectional element is available. Accordingly, you have to take less than 1. So if it is n number of cross-sectional element, then we will take n minus 1 as the dummy variable. So accordingly, because we are taking 3 forms over here, so D1Y will be capturing either 1 if it belongs to farm 1 and 0 otherwise. And if it is D2, then D2 is farm 2. If it is farm 2, then it is 1 and 0 otherwise. How does the overall figure look like? And just give me a minute. Let me tell you whether the that specification is available or not. I'm not shown here. Okay, fine, no problem. So additionally, what we have to do over here, that you have to generate another 2 variable. It is D1I over here and then D2I. D1I will be either 1 or 0. And it will be, how do you come to this conclusion? It is 1 or 0. If it is farm 1, then for the first period it is 1. Farm 1 for the second period it is 1. Farm 1 for the third period it is 1. And for the rest 6 variable, they should be 0, 0, 0, etc. Similarly, D2I, the next dummy variable, will be farm 1, irrespective of the variable, it will be 0, 0, 0. And for farm 2, it will be 1, 1, 1. And for farm 3, it will be 0, 0, 0. So in that way, we have to generate 2 dummy variable. And it is not necessarily only 2 dummy variable. I am repeatedly saying that depending on the number of cross section, we have to generate the number of dummies. If you are considering 10 farms, we'll be using 9 dummy. If you are taking 100 farms, we'll be using 99 dummies and so on. So obviously you may think that what is the advantage of doing this? So if you are taking 100 farms and if you take 99 dummies, to generate the 99 dummies also will take a lot of time. So that there lies the advantage of softwares. So in the softwares, you need not to generate all the dummies accordingly. With the help of a particular syntax or command like i.cid or i.n or something like that, you can generate that dummies in the model. So whenever we'll go into the application part, how do you generate those dummy? What is the relevance of it? I'll show it there. So this is the theoretical portion. So this is the nature of least square dummy variable model. So wherever lies there farm specific characteristics, we are doing it. Now, what is the logic behind it? The logic behind is that in the previously we said that it will capture the heterogeneity. That means if you are not sure whether the farm 1's advertisement is playing an important role, or whether it is farm 2's R&D innovation is playing an important role, or it is farm 3's foreign ownership is playing an important role, we are not sure. So accordingly, if you are not sure, then accordingly we take a dummy for that. So if you are taking a dummy for farm 1, whatever may be the non-considered variables are there, it will not club under the error term. And as you know that if the error term will be getting a lot of information, so accordingly the modeling will be not biased. I mean, it will be biased, inconsistent. So in order to make the error term free from overloaded information, we are generating this type of dummy. Is it clear?
Yes, sir. Sir, in I have one question, sir, just asking. In pooled OLS method, or we have not taken any type of dummy variables.
No,
but in case of method, we are taking dummy.
Yes. Okay. If you take the pooled OLS with dummy, then it will be ultimately becomes LSDP. That is the point that we are going to discuss. So there is no difference between pooled OLS and FE model. FE model means LSDP model. Only thing is that if you do not consider the dummy, then it becomes pooled OLS. If along with the pooled OLS, if you consider this dummy, then accordingly the pooled OLS becomes FE or a particular version of FE called LSDP. So in other words, they are interrelated. They are not completely different from each other.
Sir,
Okay, sir. Got it.
I have a doubt, sir.
Yes, ma'am.
Sir, is this LSTV model is suitable for unbalanced panel data?
I mean, from the very beginning, I have assumed that I will be proceeding with the balanced panel data. So even if for the unbalanced panel data, if you are using it, so there will be hardly any problem. So what is the problem? So suppose if you are taking 100 farms. So accordingly, for the 100 farms, all the 10 years, for all the 10 years, the informations may not be available, right? So for example, suppose farm 1 is available for 10 years. So it will be 1, 1, 1, 10 times, then 0 otherwise. But suppose farm 2 is available for only 5 years. So accordingly, for only 5 years, you keep 1, and then accordingly 0 otherwise. So accordingly, in the D1 category for the farm 1, it will
Yes.
be 10 ones and 90 0. But in
Yes.
case of farm 2, it will be only 5 1 and 95 0.
Yes, sir.
Getting it?
Yes, sir.
Okay.
Thank you, sir.
Right. So the procedure, the derivation procedure goes like this. So if you are writing the further LSDB model, now there is a importance with respect to the intercept term. Generally in econometrics, we overlook the constant term of the intercept term, but that is not the ideal case. And if you have come across with the cross-sectional data analysis also, whenever there is a dummy regression model, in that case also the particular dummy variable, the particular intercept term play an important role. Why so? Because now if you try to understand, this is the final model, and for farm 1, farm 2, farm 3, the model will be different. Why the model will be different? Because for farm 3, the D1 will be 0 and the D2 will be 0. Because the way in which we have generated, we will be generating for D1 for farm 1 and D2 for farm 2, right? So accordingly, there will be no D3, and if there is no D3, whatever is the residual is going for farm 3. So whenever there is everything is going for farm 3, so in that one, the D1 will be 0 and D2 will be 0. So when D1 is 0 and D2 is 0, whatever may be the value of beta 1, beta 2, negative, positive, significant, non-significant, doesn't matter. So accordingly, the model will be now restricted to, instead of this entire LSTB model, now the model will be beta 0 plus beta 3x1 plus beta 4x2. There will be no dummy over here. And this is the model for only farm 3, which one is considered to be a reference category. Like for any dummy regression model, we have to take any reference category. Maybe farm 2 will be the reference category, then farm 2's model will be like this. Because in our case, we are taking farm 3 as the reference category. So that's why the farm 3, the modified model instead of these will be like this. And for farm 1, the modified model will be like beta 2 D2 will be cut down because D2 will be 0. So whatever may be the beta 2 value, it will, if you multiply it with 0, then accordingly beta 2 value will be wiped out, and D1 will be completely 1. D1 will be not anything other than 1. So accordingly, if it is 1, then it will be, the intercept term will be beta 0 plus beta 1. And for the farm 2, it will be beta 0 plus beta 2. The last two, what you call the expressions remain same. The last two expressions remain same. Only thing is that the intercept term will be now changing. And that is why the importance is that whenever we are considering about the summary of the intercept value, what we are trying to understand, that find out the final model's constant term. That constant term is only for the reference category of company or reference category of country or reference category of district level. Like the previous example, suppose we are taking Brazil, India and China, and suppose we are taking dummy variable for Brazil, dummy variable for China, and there is no dummy variable for India. So accordingly, the India's intercept term will be beta 0, and accordingly for Brazil it will be beta 0 plus beta 1, and for China it will be beta 0 plus beta 2. What does it mean? That means ultimately whenever you will execute the model and find out the intercept term, there will be intercept term with respect to beta 0, beta 1 and beta 2. If the beta 0 is insignificant, that means for India, there will be no effect on the foreign direct investment whenever the x1 and x2 variable are assumed to be 0. Ultimately, what does that mean? Any intercept term means what? If all the independent variables are assumed to be 0, then in that accordingly, whatever will be the dependent variable. So the question arises, how does the dependent variable will come? It is the same case as you start with the fundamental law of consumption of Keynes. that whenever consumption is a function of income, even if your income is zero, there may be some consumption, what we call as autonomous consumption, isn't it? So autonomous consumption may be zero, autonomous consumption may be positive, autonomous consumption may be negative also. So in that way, we are doing this analysis over here. So like suppose India's case will be positively significant or whatever, so that will be the case. Ultimately, if this will be if this is not statistically significant, then Brazil's intercept term will be only beta 1 and China's intercept term will be only beta 2. Otherwise, if the India's intercept term remain positively significant, then accordingly, Form 1's intercept term indicates that Brazil will be ahead of India by the amount of beta 1 and China will be ahead of India by the amount of beta 2, so far as foreign direct investment is concerned. Is it clear?
Yes, sir. It's clear.
So next thing is that how do you compare between pooled OLS and LSTB model? Obviously, there are multiple ways available. I've only mentioned about two portions over here. And whenever we'll be going for the techniques of how do you execute in the data or etc., it will be getting clearer. So obviously there are many versions. Whenever we are comparing between any two model, I'm sure that you might have covered something called model specification criteria. So there will be many criteria available like AIC criteria, archaic information criteria, Bayesian information criteria. So accordingly, adjusted R-square is another also available. F-test is available. Wall test is available. So in that way, we can compare between two models. So in that way, whenever there is a confusion, pooled OLS and FE-LSTB model, then accordingly which model to be chosen, then go for both the models, find out their respective adjusted R-square F-test comparison. If the F-test is model 1 is more in comparison to the previous one, then the model 2 is better than model 1. And accordingly, there will be many procedures are available to come to the conclusion which one is better. And that is also the case for FE and RE also. But obviously, there is another robust procedure available, what we call Haussmann test, and that will be giving us some better clarity. And we'll be proceeding further whenever we discuss that. I have already consumed almost 1 hour. So there will be many other description part also like within group estimator. So what happens in case of within group estimator, like the overall model is like this. This is what we call firm specific characteristics or cross-sectional specific characteristics. Now what happens in case of within group estimator, you find out the mean value of the dependent and get each observations of the dependent variable minus the mean value. And whatever is the mean value over here, it is the mean value across the time period. To give you a better clarity example, like for example, 231, 334, 436, these are the three variables. And this is 231 is yi1. This is something called y1 t minus 1. This is y1 t minus 2 and so on. So find out the average. That average is something called whatever may be the average 333 or something we have previously got obtained. So if you find out through 231 minus 333, 334 minus something, 333, 436 minus something. So what we are generally doing over here, we are going for a demeaning the variable. So whenever we are demeaning the variable, so that is the concept of within group estimator. That means we have find out the average figure of the dependent, and from the each variable of the average figure of the dependent, find out minus it mean value. Similarly, from the first independent variable, find out its mean value and then subtract it. So it is demeaning the first independent variable. This is demeaning the second independent variable. And accordingly, the similar procedure will also be applicable for the country specific characteristics and their error term. Now there lies the advantage of LSTP over WG over this LSTP, because once we'll go for this type of averaging, so obviously there is no time specific element over here because the cross sectional element is capturing only the time invariant factor, because they are cross sectional, only form specific characteristics. So accordingly, in this variable will be exactly equal to this, and that's why they will be getting cancel out each other. So derivation portion indicates that if you rewrite the analysis like this, so this is the demeaning dependent variable, this is the demeaning first independent variable, this is the demeaning second independent variable, and all the form specific characteristics that we start with the assumption that they remain present. By the help of within group estimator, we cancel them each other. That means we take into consideration the heterogeneity, but ultimately at the time of doing the analysis, we cancel out each other because we have modified the LSTB model to within group estimated model. So accordingly, whatever is the rest model is nothing but a d mean dependent variable, is a function of d mean independent variable 1 and d mean independent variable of 2. Now, if you try to understand that is that whether this beta 1 will be the same as the previous beta 1, obviously no, because you have put a filter. What is the filter? That find out the mean value and get the mean value is subtracted from each observations. And obviously, if you remember the regressions models principle, any regression, no need to do the econometric analysis. The regression is independent of origin but not of scale. Do you remember that?
Yes, sir.
Yes, sir.
What is actually the concept, whether it is independent of origin or not of scale, or it is independent of scale and not of origin? What is that particular concept?
Independent of
The
origin,
first
not
one.
of scale.
It is independent of origin but not of scale, right? So that means if you multiply any 2, 3 or some other transformations, it will be reflecting. But if you go for addition or subtraction of any constant, then that will be not going to affect it, isn't it?
Yes, sir.
On that principle, we have subtracted the mean value and get the d mean factor. So in that way, both the variables will be like the previous modeling and this modeling will still be relevant. If you multiply something like 2 or some alpha or some lambda or something like that, the modeling will be different. So that is the advantage over here. That means we are going for a modified version of fixed effect model. So first one is pooled OLS. Second one is with pooled OLS, if you add dummy, then it becomes LSDB. Then with the help of the dummy variable, if you are going for the subtraction of the mean value, then we call it as a WG model, which we call within group estimated model. And there will be similar concept with respect to dynamic fixed effect model. I am not gone into that part of the dynamic fixed effect model, the DFE model. The last part of the story is something called the random effect model. So what is the concept of random effect model? The random effect model is basically a sandwich model between the two. Like again recall, there is a perfect competition, there is a monopoly market structure. Perfect competition is an extreme version of market, monopoly is another extreme version of market. Rather, the realistic market situation is neither monopoly nor a perfect competition market. Anything related to oligopoly or monopolistic competition is actually the case, isn't it? So in the similar line of argument, the random effect model is always lying between the two. It is not exactly the d-mean factor. It is not exactly not considering the heterogeneity ourselves. Rather, the random effect model will consider the heterogeneity aspect and it will apply the d-meaning effect. But the d-meaning effect will be, before going to the d-meaning effect, now the intercept arm is not capturing this what you call the form specific characteristics or the unobserved heterogeneity. Rather, the unobserved heterogeneity will slop together with the error term. And the error term will be a bigger term because it is not only capturing the form specific characteristics, but also the other than two variable, whatever is the residual variable. For example, FDI inflow is a function of GDP per capita and exchange rate volatility. But obviously we know that FDI inflow is not only a function of these two variables. There can be other variable like political situation, governance factor, institutional factor, monetary sector, stock market, what you call trajectories, etc. So all those things which is not covered in this model, they are ultimately capturing within this epsilon term, right? Which we call is the error term. Now in the random effect model, we are again overvaluing the error term with the help of the farm heterogeneity. Whereas this farm heterogeneity was previously, in case of fixed effect model, was related to intercept term. Now, either you keep it in the very beginning of the, like in a locomotive, in a railway thing, either the engine will be at the top, I mean at the very initial stage, or it will be at the towards the residual stage, right? There is no meaning of getting an engine in the middle portions of bogies, right? So in that way, the random effect is actually taking into consideration the heterogeneity towards the end, whereas in the fixed effect model, we consider this heterogeneity towards the beginning. So intercept related analysis is fixed effect model, and residual related analysis will be something called random effect model. And ultimately what happens, the model will look like something like this. I'm keeping them together because there will be very hardened thing will be available over here. So ultimately the random effect, which is the GLS transformations, it will be look like something this. It will be similar like within group estimator. Now what happens over here, instead of taking YIT minus Y bar, there is something called a lambda figure will get into the picture. And this lambda figure is actually taking into the difference between a fixed effect and something called the OLS model. And this lambda figure is basically a decimal figure. The decimal figure will be something like this. If the decimal figure will lie between 0 to 1, if it is close to 0 or if it is exactly 0, then the random effect model becomes the same as pooled OLS. And if this lambda becomes 1, then this random effect model will be fixed effect model, which is within group estimator model. So in that way, neither the three versions are completely independent to each other. Pooled OLS is related to fixed effect. Pooled OLS is also related to random effect model. Random effect is also related to fixed effect model. So in that way, all the three things are interrelated with each other. And then subsequently, how do you come to this conclusion which model will be selected? For that, I have to take a break now. I have to switch over to another PDF. Is this PDF visible? Obviously, this PDF is not prepared by me. This type of PDF, this is actually my starting point of my PhD journey. I started my PhD journey in 2007 January. So during that time, the Princeton University, they have come across with a what you call lecture note series. And this lecture note series, I always recommended, irrespective of the nature of the audience, whether they are very learned or whether they just the PhD scholars or they are in the middle categories. So this is a very good, only 50 pages material, which will give you a very sound, what you call understanding with respect to the panel data modeling with the help of stata. So obviously our objective is not to get into the previous examples to execute. Rather, my objective is to how do you do the analysis in the help of a stata model. So obviously the panel data, how does it look like, etc. I have already shown it. So there is no point in discussing them again and again. So what happens over here? How do you prepare the data? So generally the data will be not available in the form of long form. Rather, long form means longitudinal form. In other words, panel data form. Rather, the data will be look like something like this. Like for example, here there are 7 countries are there, and for 7 countries, for any specific variable, maybe GDP, maybe FDI, etc., 95, 96 up to 2005, the data is available. So this is the nature of the data. Obviously, this data is not meant for any analysis because this is not in terms of long form. Rather, we call this type of formation, it's called wide form. Generally, in the Excel file, whenever we collect the data for each particular variable, like for FDI in the sheet 1, this is the nature of the data arrangement. In the sheet 2, there will be GDP per capita. This will be the nature of arrangement. In the sheet 3, there will be suppose exchange rate volatility type of figure, or there will be another arrangement. When there are different sheets, how do you take it to the stata and do the execution? Obviously, in a sheet 4, all the 3 variables should be taken into consideration. So that's why, to start with, the wide form of data, which we generally come across, that should be converted into a long form. And there is a procedure to import the data into the stata, and there is a procedure to something called reshaping the data. So once you reshaping the data will be arranged in terms of the ID here. Over here is the ID for the different countries. Like over here we are having 7 countries. So all the 7 countries, the first country is available for all the years. Then the second country starts, and it will be starting from 95 to 2005. Then for the third, it will be continue. Obviously, this is not the end of the database. Scrolling them down, we will get the entire database. This is just a screenshot of it. So in this way, first thing is that how to import the data to the stata, and then from the wide form, how do you reset the data into a long form. Once you are doing the long form analysis, then we'll be going for the further type of analysis. So next thing is that if there is after reshaping the data, if you come across with any string variable, then how to modify the string variable, etc. If there will be more than one variable column, then how to finding out, etc. So to come across with everything, then the third version is that how to declare the data. Now everything whenever they are converted into long form, we have to set the data and declare the data as panel data. So this is the way in which we do it. Generally, X represents the cross section in the data and T represents the time period. So whenever you are writing XT, that is the syntax for the data. To understand that, we are going to analyze the data with respect to the panel data framework. Unless until you declare the data to be panel, it will be considering as a pool data. So if you, instead of writing xt something something, if you just writing go for regression RECY x1 x2, it will go for a pooled OLS. So how do you execute it? These are the visualization of data for different country for a particular.
Voice is not audible, sir.
Sir,
हाँ मैडम जॉइन করছি. I'm sorry for this technical problem. Some power off is gone. So, am I audible now?
yes, sir,
Yes, sir, now you are.
Okay. I'm sorry for the disturbance. Okay. So, going briefly, I should be brief because it's almost time now. So, where we are? It was something related to the visualization thing. Now, once we have done the visualization, the next thing is that visualization. Yes.
sir, please share your screen, sir.
Sorry, is it now? Okay.
Yes, sir, share your screen, sir.
Oh, okay, okay. Is it visible?
Yes, sir.
Okay. So next thing that once you declare the panel data set, the next thing is that for any data, for any analysis, we may visualize the data. How does the data look like? So there are many ways of visualization, whether the line data, histograms, etc. Many things are available in this slide. Then we are, if we are going for the fixed effect model, then the different modelings are also available. This is the nature of the panel data. How does it look like for a particular variable? So if there is a necessity for any transformation, This is an important portion. Generally, I take I mean, give a detailed explanations with respect to it. Majority of the time, what we are doing basically as a researcher, and that to South Asian researchers, that to Indian, and that to Odisha. So what we generally consider it as there is a syndrome. I generally consider it as a syndrome. We call it as a star significance syndrome. Please don't laugh at me, but this is a very important challenge or a problem with respect to a researcher like us. That what we are interested in finding out the star, where does lie the star, whether we are getting more stars, then accordingly the significant level will be high, then the result is good. So we are not bothered about the theoretical frame or the other things into consideration. And I generally crack this poor joke. Hello.
Yes, sir, you are audible.
Sir, you are audible, sir.
Yes, sir, you are audible.
Okay, is the screen visible now?
Yes, sir.
Okay.
Sir.
Okay. So what we generally do that once we import the data, so we go for a descriptive statistics. So the descriptive statistics command is like this. So depending on the objective. So if your objective is to go for summarization, summary table, so you just write SUM is the command. Then on the series, the dependent variable should come into the first. So GDP per capita, according to this particular presentation, they are taking GDP per capita as the dependent variable, the trade openness as the first independent variable, and the labor force participation is the second independent variable. So accordingly, if you just give a command like sum, so these are the nature of the variable that you come across. That means all the three variables, the observations and the mean, the standard deviation, the minimum value, maximum value will get into the thing. And what is the difference with respect to normal sum and xt sum? As you have already mentioned, if you give extra command called xt, it will be analyzing from the panel data perspective. So the similar observation, similar summary statistics that we come across over here, in the presence of the panel summarization table, panel summary table, it will give us for the same variable three versions. One is the overall version, second one is the between version, third one is the within version. So if you recall, the mean value will be the same 14,925.78 and the overall value will be the same. Whereas the between and the within variable, they will be different. And that is for the only standard deviation as well as for other minimum and max value. What does it mean difference between within? That means for any cross-sectional observations, if you assume the time period to be fixed, that means if there are suppose 7 countries, so how does the country's standard deviation figure if you assume that the time period is fixed? And that is give rise to something called the within standard deviation. And similarly, if you assume that for the same year, how does some standard deviation is varying from country 1 to country 2, country 2 to country 3, etc. So there is a between level. So there are 3 versions of it. One is the overall category, that is for the normal, and between category, that means across the what you call time across the cross section, assuming the same time period, and within is assuming the same cross section over the time period. So these are the 3 versions of summary table. Similarly, if you use the fixed effect model, the fixed effect model will be xtrez is the command. If you see the xtrez is the command, then the dependent variable, independent variables, and other estimations are given. So these are the snapshots where you can see that how does the model look like. That is available over here. Something in the first top corner of the red button thing. Then it will give you a very detailed analysis that how does the each component is interpreted. What is the meaning of the p-value? What is the meaning of the different coefficient? What is the different robust standard error, etc. So in that way, this particular slide, this particular presentation will give a very systematic analysis with respect to fixed effect. Then there will be something called the advanced version of the fixed effect called the SD fixed effect model, the high definitional fixed effect, where there will be multi-way effect, there will be one-way effect, there will be two-way effect. I'm sorry that this is not possible right now to cover every one of them, each one of them. What I try to cover them is that ultimately similar procedures can be applicable for random effect model. And how do you interpret that, whether it is a fixed effect or random effect, or whether it is a pooled OLS method? What we generally do is this is the procedure. This procedure gives us a Haussmann test. So what you generally do, you go for the fixed effect model first, then store its estimation. Then you execute the random effect model, then store its estimation, and then use the command called Haussmann fixed and random. Here, in this case, it will give you a picture with respect to a chi-square distribution value. And the chi-square distribution value will give you a picture that whether that chi-square value is significant, statistically significant or not. For any statistical significance, you have to find out its probability value. The probability value should be as small as feasible, that is better. So if the p-value is very close to 0, or basically the rule of thumb is that if it is less than 0.05, then in that case, the model indicates that the fixed effect model is better than the random effect model. So once you understand the fixed effect model is better, so accordingly, you can use the robust estimation to capture or to nullify the other possible problems arises in this model called the heterogeneity problem, the serial correlation problem, etc. How do you find out whether there is any diagnostic checks for the fixed effect? So first thing is that within the fixed effect, there is a feasibility that not only the cross-sectional dummy will be taken into consideration, but also it is possible that you may consider the time period dummy. So like in your previous example, suppose we are taking Brazil, India, and China. 3 countries are there and 5 time periods are there. So if you take a fixed effect model, then you have to take two dummy for the cross-section. Now for the time period also, because we are taking 5 time period, so accordingly we may take 4 time period dummies, and whether those time period dummies are relevant or not. So there is a diagnostic checks for that. It will give us a F value distribution, and if the probability value of that F distribution is significant, then accordingly there is a necessity to keep not only the cross-sectional dummy but also the time dummy. And if you consider both the cross-sectional dummy and time dummy, we call it as a two-way fixed effect model. Otherwise, it is normally considered as a one-way fixed effect model where the cross-sectional dummies are taken into consideration. But if there is a necessity of taking a time dummy, but you have not taken into consideration the time dummy, then accordingly your result will also be biased and inconsistent. So accordingly, you have to be very careful that whether you will go for a one-way fixed effect or you will go for a two-way fixed effect. Then similarly, there is a procedure available for something called the
Sir,
random. Yes.
I have one question. Like
Yes.
you have been telling us कि हमें क्रॉस सेक्शनल है तो ऐसे डमी लेना है और देन एज पर द सिग्निफिकेंस वैल्यू वी विल कंसीडर कि डमी वेरिएबल्स टाइम सिग्निफिकेंट है तो टाइम वाला डमी ले लिए एंड क्रॉस सेक्शनल है तो क्रॉस सेक्शनल. The same procedure will follow in the GMM.
In the GMM, it is actually depends on. It is depending on. There are two versions of GMM. One is called system GMM. Another is called difference GMM. If you have come across with the GMM model.
Yes,
So
sir.
in both the
Two
concepts, there
system GMM.
is a concept of taking either for time dummy or country pair dummy. So in the system GMM, it is a by default both the dummies are available. Whenever you give the command will take into consideration both of them. The two-step GMM and one-step GMM is different thing. But normally GMM, whether it is system GMM we are talking about, then system GMM, not only the cross-sectional dummy, but also the year dummy has to be taken into consideration. It has to be there. But in the difference GMM, there is a chance. I mean, it is up to. There are different versions of it. Actually, the GMM is not that simple, right? So what happened? There are multiple filtrations you have to take into consideration. First thing is that whether it is system or difference. One is applicable for system, then whether it is one-way system, then whether it is two-way system GMM. Then one you final it's as a one-way or two-way system. Then you have to find out their serial what you call. I'm not getting it. There are two diagnostics available. One is Sargent test. Another is some other test. Then whether they are applicable or not. For that, one is capturing over identification. Another is applicable for endogeneity test. So there will be that analysis is relatively complicated. Here we are not going into that detail. Here our objective is that whether you are once you decide that pooled OLS is not good, pooled OLS a random effect may be better than pooled OLS, then you can check from the Horseman. Then second is that whether random effect se bhi better fixed effect mein bhi milega, then accordingly you go for another Horseman test to verify fixed effect. Now, once you settle down that no way pooled OLS is good nor random effect is good, we will be settled down for fixed effect. Then in the fixed effect, whether it is one-way fixed effect or two-way. Here, this will give you a picture that whether two-way fixed effect is required or not. This type of result will give you an impression that one-way fixed effect is not good. Rather, we should go for two-way fixed effect because time dummy the consideration is relevant over here. So if you do not consider, then accordingly the problem will be there. So better to consider it.
Okay, sir.
Okay. So similarly, once you find out the random effect model, the random effect model is also can be verified with respect to pooled OLS and something called random effect, where which one is relatively better. So there is something called Bruce-Pagan Lagrangian multiplier test. So that will give you another interpretation that is also a chi-square distribution, and it will give you a picture that whether pooled OLS is better or random effect. Try to understand the pooled OLS is generally assumed to be the not so good. Random effect is considered to be the middle category. The fixed effect is considered to be the best one. So accordingly, if the pooled OLS random effect is considered, then first check with the BPLM test, which we call Bruce-Pagan Lagrangian multiplier test. If it supports a random effect, then go for Horseman. Then random effect and the fixed effect can be compared. Then after Horseman test, you can verify whether it is one-way fixed effect or two-way fixed effect. So this is the ideal way of doing the analysis. Start with pooled OLS and end with two-way fixed effect. Then once there is a two-way fixed effect also, the other type of problem may arises, like there is something called there is a possibility of heterogeneity, there is a possibility of serial correlation, there is a possibility of cross-sectional dependency test. So there will be n number of diagnostic checks available. Once you can explore them all together, finally you will use something called a fixed effect VCE robust. It will give you a heterogeneity, autocorrelation, multicollinearity adjusted robust standard error. So that is the final step so far as the pooled OLS, FE and RE model is concerned. Now, the last point that I want to touch upon before going to conclude my statement, that whatever we are discussing right now, these are very elementary in nature. So any starting point of analysis of any cross thing will be there. Now, the final thing is that if you want to proceed further, now if you want to go ahead with the analysis, so this is a snapshot that I want to share with you. This is I have compiled from various sources. So the advanced panel data modeling, how do it look like? So there are two broad tests. One is the endogeneity test, another is a cross-sectional dependence test. The endogeneity test, if there is if it is giving us a indication that there is an endogeneity problem, so accordingly there are other types of modeling take place, which we call the two-stage least square model, the LI maximum likelihood method, the FI maximum likelihood method, and the GMM model. So GMM model is basically, or similar type of version, similar family of modeling is applicable when there is an endogeneity problem, endogeneity issue. Second version of the problem is called cross-sectional dependency. So cross-sectional dependency indicates that if you are taking the multiple cross-sectional observations, whether the cross-sectional observations has any time 1 to time 2, time 2 to time 3 interdependence or not. If there is there, then accordingly there are two types of interpretation. Either CD test confirms that there is existence of CD cross-sectional dependency, or there is no cross-sectional dependency. If there is no cross-sectional dependency, then first generation unit 2 test analysis will be there. If there is a CD test confirms that there is a cross-sectional dependency, then there is a second generation test will be, unit 2 test will be conducted. Then within the second generation within root test, there will be either the situation that the dependent and independent both variables are stationary. Then we use the common correction effect model. If you come across with there is a non-stationarity and the dependent variable is integrated out of order 1, and the dependent variable is integrated out of order 1, and independent variables are mixed in nature, then accordingly there will be different types of co-integration, like Westerland co-integration, Pedroni co-integration, Demistry-Hedlin co-integration test. Then accordingly Granger causality, the dynamic common correction effect regression model will be conducted. So this snapshot will give you an idea that where lies the pooled OLS, FE, RE, and another version of it called the seemingly unrelated regression model. So basically they are related to the CD test does not confirm, and accordingly the first generation unit 2 test conducted, and what we are finding that all the variables are stationary. So if you are taking 3 variables, not only dependent, but also all the independent variables should be stationary. Then if they are stationary, then the pooled OLS model will be useful, or the FE-RE. And accordingly, among the FE-RE pooled OLS, using the Hausman, we can come to the conclusion that FE is better over RE, or RE is better over OLS. And accordingly, one way, two way, a fixed effect model will be related or not. So with this, I end my discussion over here. So if you have any observations or any query, then please ask me so that we can have a discussion for at least 5 minutes, if not more than that. Anyway, I have already crossed for 6 minutes more.
So basically, I'm going to use the 2-step JMM in my model. So
how do you know that you will use 2-step JMM?
Actually, sir, that is with my discussion with my supervisor, and as
discussion cannot give you an analysis. answer that
actually I have done the literature review and see
literature review will not give you an answer. It is completely on the basis of the diagnostic. Before going to use GMM, you have to verify whether it is long panel or short panel. GMM is applicable for only short panel. For long panel, GMM is not applicable. So have you checked for the short or long nature of your panel data?
No, sir. Till the
Yes.
time I'm not done
So that is the
any
first step.
diagnosis.
Next thing is that whether you will be going for dynamic panel or not, that depends on the nature of your discussion.
Sir, I'm going for the dynamic panel.
Yes, I mean, how do you come to that conclusion? It is
Next,
not. See, please don't take it. Otherwise, it is not you. Anyway, I'm not in a position to see your face also right now. I'm still in my slide. So please don't take it. Otherwise, what I suggest is that generally we prefer that whichever model sounds to be very critical, very widely, available in the current journals. So that is the ideal most way. That is not necessarily be true. Pooled OLS is the best one. But the thing is that obviously it characterizes many other problems. Once we verify, then accordingly we can say that okay, there is endogeneity, there is a necessity for GMM. If there is endogeneity, if it can be handled with 2SLS model, why you should go for GMM model? 2SLS model is also a dynamic model.
yes,
Are you getting my point?
yes, sir.
So, are you a Odia or not Odia?
No, sir. I'm from Delhi.
ओके तो लेट मी टेल यू हिंदी अगर कोई चीज मतलब सूची से हो जाएगा तो उसके लिए बड़ा लोहे का चीज लेने की कोई जरूरत नहीं है राइट
Yes, sir.
स्विंग मशीन के लिए लोहा चाहिए तो हमको वो बड़ा वाला लोहा नहीं चाहिए वो तो स्विंग मशीन के लिए छोटा वाला हमको
Swing.
निडल चाहिए ना तो निडल से हो जाएगा देन करना क्या है जीएमएम से
Okay, sir.
okay but it is not only to you, it is generally I also get tempted many times to use the sophisticated so-called sophisticated models but there is nothing called sophisticated in this. It is completely depending on this. Suppose you go for the PPBS or the test, and if that test is meant for only finalizing that what is the glucose level in your blood, then accordingly it will give you an impression with respect to whether diabetic or not diabetic.
Yes, sir.
It is not the case that whether it is diabetic or not diabetic will go for treatment, isn't it?
Yes.
So first go for the diagnosis. If it is relevant, then go for the advanced one. And whatever this
Can
GMM
you,
system, GMM dynamic
sorry for
GMM,
interruption, but can you suggest some book for this panel data analysis?
there are many books are available nowadays, ma'am. There is no need to tell any student or any researcher to go for any book. Anyway, my last slide is with respect to some informations available. We do not come into that generation where the books are only the final versions available. So that's why I have deliberately given three types of references. If you recall, if you see, the last one is a YouTube NPTEL channel, right? So in that channel there will be n number of informations available so far as how to do a model, what is the different procedure, how to do it in the views, how to do it in the spaces, how to do it into the stata, how to do it Python. So there are many versions available so that you can
Just
get
to
you from.
suggest the students, sir, because
Yes,
we are
ma'am. This is,
to
every one of
suggest
us is a student, ma'am. I mean, I am a student. You are also a student. So there is no point in saying that we know everything, right? We have
No,
our own
we
limitations.
don't know. Actually, we are lagging
Yes.
far behind our students
True.
who are actually using
ma'am.
online and this
Yes,
data
ma'am.
and all this.
So the first one is a recommended textbook which is across all the what you call universities, including Odisha. We are actually first of all, let me tell you, I'm a product of Revensa University. I did my graduation over there, and I am the first batch of Revensa faculty also. From 2010 to 14, I was the Revensa PG department lecturer. Right. So during our time, we tried to make a changes in the Revensa University syllabus, and these are the syllabus I used to teach game theory, optimization, and econometrics. So we should not say that we are the pioneers of econometric changes in University of
That's
Odisha.
true, sir. I am also a faculty in BJB Autonomous College, and we
Yes,
are
ma'am.
also prescribing this Damodar Gujarati and other books.
Yes, but
Things
yes,
are
ma'am.
that
But
our
recommending.
students are learning faster than us.
True,
because
true.
they are
They
using-
will learn. They belong to Gen Alpha, Gen Beta generation, ma'am. And we are millennials or maybe Gen X. I do not know. I come under the millennial category. So in that way, we are definitely lagging behind. So we are very okay with doing Excel analysis, and our PhD
Yeah,
thesis
that's
was
true.
awarded.
That's true. Actually true, and therefore we have to learn always to keep up at least updated to
True, ma'am.
somewhat extent.
True,
And
ma'am.
I also request you to kindly share your PPTs, sir.
Yes, sir. It will be available at your fingerprint within a minute, ma'am. I'll share with you with Jyotirmay ma'am WhatsApp. I generally believe in dissemination of the PPT because anyway, this is not my parental property. I have compiled it from various sources. So obviously there will be no problem with respect to sharing the PPT, ma'am.
Okay,
I'll
sir.
be doing it within a minute.
Thank you, sir. Thank you very
Thank
much.
you, ma'am. Thank you.
Sir,
Wish you all the very
I have
best.
one question, sir.
Yes,
Just
ma'am.
I
Yes, sir.
want. Sir, what is the meaning of endogeneity and why it is tested, sir? And what is its uses, sir?
Just a minute. Huh. So, can you repeat once the question?
Sir, I am just asking about the endogeneity, sir. Concept of endogeneity
Endogeneity.
and why it is tested, sir.
Okay. See, this is a completely different story altogether, but okay, let me try. So, suppose there is a dependent, another is an independent variable, right? So, what happens over here? So, or maybe we take the two independent variable. X1 is one independent, another is X2. Now, the thing is that the error term, they might have a relationship with the independent variable, any one of the independent variable. So there are actually three ways of doing this endogeneity analysis. One is a simultaneity issue. Simultaneity issue means what? That price is a function of quantity demand. Quantity demand is also a function of price. We generally confuse our student by saying that only the price is the dependent variable, independent variable, and quantity demanded is the dependent variable. That is not the case. The quantity demand will be more, the price will be also more. But the price will be more, the quantity demand will be less. Because that is a microeconomic aspect, right? Price is the independent variable according to law of demand. But that is from the consumer's perspective. If you consider the producer's perspective, obviously quantity demand will be more. In the market, there is more demand. So accordingly, price will be more. So how do you say that a price is an independent variable and quantity demand is an dependent variable? Are you getting my point? Are you from economics?
No, sir, I am from commerce, sir.
Okay, but are you getting
Yes,
this
yes,
example? This is
yes,
for this the
yes.
hardcore economics knowledge
No,
is
no,
not
no, sir,
relevant.
no, sir, no, sir, no, sir, no,
Okay.
sir. I'm
So
getting.
generally we come across with this problem. So whenever we are confused that whether Y is a dependent or X is a dependent. So that means both the variables may have interdependence with each other. That is the concept of simultaneity bias. So once there is a simultaneity bias, there is a problem of endogeneity. That is one possibility. Second possibility is that you try to frame a model and then you come across with something that the error term and the independent variable, they are interrelated with each other. That means if you know that there are certain variables need to be incorporated, but because of data unavailability or because of something else, you deliberately do not consider them in the model. So obviously one factor is not modeled, that will go into the error term, and error term will be loaded. And as the error term will be heavily loaded, there will be less what you call effectiveness of any kind of regression, whether it is dynamic panel, whether it is any modeling, right? So there is no such problem with respect to the error term should be free from any external variable. So in that case, that will also give rise to something called the endogeneity problem. So there are multiple ways, multiple regions behind endogeneity. Once we understand the regions behind endogeneity, then you have to recommend that for which problem, which type of modeling is relevant. If it is a simultaneity bias related endogeneity issue, then 2 SLS or 3 SLS model can be useful. There is no need to go for the GMM estimation. But if there is a problem with respect to not only endogeneity, but also simultaneity bias, but also for other regions like model misspecification. Suppose there is a Cobb-Douglas function and you take it as a linear function. So accordingly, there will be a problem. Your model is not well specified. So accordingly, for that analysis, we need to go into the GMM estimation, where it can handle a relatively better one. Every model, every sophisticated models is actually coming with certain filtrations. more filtrations, more better result, there is no guarantee. So with less filtration, if you can get better result, that is the beauty or that is the challenge of for a researcher. Is it okay?
Okay, sir. Thank you, sir.
Thank you, sir, for such an engaging session. The discussion on panel data econometrics delivered by sir has been highly informative, insightful, and intellectually stimulating. This session provided a comprehensive understanding of panel data analysis, highlighting its significance in empirical economic research and its advantages over cross-sectional and time series data. Now, I request our co-coordinator, Dr. Diptimai Samal, to give a vote of thanks.
Thank you, sir. As we conclude today's session, I would like to take this opportunity to express my sincere gratitude to our esteemed resource person, Dr. Ajit Kumar Sabat and Dr. Vikas Ranjan Mishra sir for their insightful presentation, enriching deliberation and valuable contribution. We are extremely thankful to you, sir. I extend my heartfelt gratitude to Professor Biswajit Patnaik, sir, Honorable President and founder of ASBM University, for his visionary guidance and enduring support. I am immensely thankful to our esteemed Vice President, Vice Chancellor, and Principal Director for their encouragement and cooperation. I would like to thank all the faculty members, coordinator, co-coordinators, technical support staff, and all the participants for their active involvement and contribution to the success of this program. Thank you all for your presence and participation. We look forward to meeting you again tomorrow at the same time for enriching session. Have a beautiful evening. Thank you, sir. Thank you.
Thank you, madam. Thank you.
Thank you, sir.